Hello, one and all. My name is Rohini. I'm working as Assistant Professor, CSE Department, Velamal Engineering College. Today, we are going to discuss the subject Cloud Computing and Virtualization. In that, Unit 1 is Introduction to Cloud Computing, which contains the definition of cloud computing, evaluation of computing paradigms, and what is parallel and distributed computing, and cloud characteristics, and what are advantages and disadvantages of cloud computing, and elasticity in cloud, and on-demand provisioning. So the first one, we will see what is cloud computing. So cloud computing means using internet based services like server, storage, database, networking, software and analytics whenever we need, and pay as you go. Like we are going to use resources whenever we need remotely, and we can pay how much we are using. So it is basically accessing and using computing resources like app, file, servers remotely via internet without using, storing and running in PC. So cloud computing is important because it offers scalable, flexible and cost-effective technology access. So it's used to grow business faster and used to manage IT resources more efficiently and provide security. So it widely used on IoT, big data and artificial intelligence. So mainly the benefit is cost reduction, increased flexibility, scalability and enhanced collaboration. Because cost is reduced because resources are shared, and increased flexibility and scalability, we can add any number of resources. We can scale up or scale down number of resources. So the cloud computing is categorized into deployment model and service model. In deployment model, we have public cloud, hybrid cloud and private cloud, and one more community cloud is also available. In service model, we have three services. One is infrastructure as a service, IaaS, and platform as a service, PaaS, and software as a service, SaaS. First, we will see what is deployment model. A deployment model defines the environment where your cloud application run. So it can be your private system or a public cloud like AWS or mix up of both. So the public cloud is owned by third-party providers and it can be shared. And private cloud is nothing but it is designated to single organization or single user. Hybrid cloud is like a mix of both public and private cloud. And the last one, community cloud, is designated to specific community. And this is a diagrammatic representation of each cloud. The first one is private cloud, which explains two. One is on-premises private cloud and the second one is externally hosted private cloud. In on-premises private cloud, the enterprise P and cloud service provider are located in same place. But in the externally hosted private cloud, the cloud service provider and enterprise P is their premises is different, means they are located in different place. And public cloud means any enterprises or any users, any public can access this cloud services. Like here, enterprise P, enterprise Q, and user R are sharing the cloud services. And the next one is hybrid, which is a combination of private and public cloud. And the last one is community cloud. So in the community cloud, different enterprises like P, Q, R are using the cloud services, which is dedicated for specific community users. And so this is the overall diagram of this deployment model. So private cloud for particular organization, and public cloud for all, and community cloud for specific community. So hybrid is nothing but a combination of all this. The next one is a service model. So a service model in cloud computing describe how cloud services are delivered to users. So there are three services are given. One is infrastructure as a service, which provides virtualized computing resources like servers, storage, and networks. Examples are given here. And the second one is platform as a service, offers a platform to develop, run, and manage your applications without managing the underlying hardware. Example, Google App Engine, Microsoft Azure App Services. The third one is software as a service. It's like ready to use applications, Gmail, etc. So it delivers ready to use software application over the internet on the subscription basis. Like how much you are using, you can pay and use it. So this is the overall diagram of deployment model and service model. The deployment model we have seen in detail, and here the service model. The first one, infrastructure service, where so the networking, storage, server, and visualizations are controlled by service provider, and the remaining are controlled by customers, like application, data, runtime, middleware, operating system. So infrastructure is provided, so customer can use and execute it. And the second one is platform as a service. So from networking to runtime, the provider is going to control and manage only the application and data the customer is going to manage. So the entire platform is given, only users can or customer can use their application and with their data. And software as a service is like ready-made software, which is like entire software is given to the user, which is controlled by service. Means all the layers from networking to application is controlled by service provider. So the next one is evolution of computing paradigm. The first one is, in this evolution, this is a diagram for evolution where it starts from 1915 until date. So it starts from distributed computing, mainframe, cluster, grid computing, virtualization, web, service-oriented utility, and cloud computing. So the mainframe computing, the traditional mainframe computing is nothing but it's a centralized system where users access powerful mainframe via terminals. Okay, so the mainframe computer acts as a centralized system where we can use it via terminals. And the second one is distributed system. So the computing power is spread across connected systems, means devices can use this distributed system for computation and enable scalability and fault tolerance. And the third one is cluster computing. So multiple computers work together. So cluster means just combining computers together. So multiple computers work together as a single system to perform high performance task. And the next one is grid computing. So grid computing is nothing but how geographically distributed resources coordinated to solve complex computing problems collaboratively. Means the resources are located in a different geographical spaces. And the next one is utility computing, where computing resource offered like a utility based on pay per use. How much we are using, that much we can pay and go. And the next one is virtualization. So virtualization is nothing but enabled multiple virtual machines on a single physical machine to improve resource utilization and flexibility. And the next one is Web 2.0. So it's an interactive web application emerged and promoting user-generated content and collaboration used for web application development. And service orientation. So it's an introduction of service-oriented architecture which promotes modular and reusable software services. And so the next one is cloud computing, which combines all prior advances to deliver scalable on-demand computing service resources over the internet using models like IaaS, PaaS, and SaaS. Cloud computing means it provides cloud computing services like IaaS, PaaS, and SaaS. So this is the diagrammatic representation of evolution of cloud computing. And so the next one is parallel and distributed computing. So parallel computing is nothing but it's a computation method where multiple calculation or process are executed simultaneously to solve a problem faster. Means different process or multiple process are executed parallelly to solve a big complex problem in a faster manner. So breaking down a problem, big complex problem, into smaller independent sub problems, and it can be solved parallelly or concurrently. The benefits are like speed up execution, because problems are executed parallelly, and handle large data and improve performance. Examples are given here. And the next one is distributed computing. Distributed computing means where multiple computers work together over a network to solve a problem. So the complex problem is distributed to multiple computers. So tasks are shared across several connected systems to make faster processing, better efficiency and reliability. Example is Google search and AWS. Benefits are handle big problem efficiently and share resources effectively, and more scalable and fault tolerant. And so this is the overall how parallel versus distributed computing in cloud. So cloud computing uses both parallel and distributed computing. So parallel computing runs multiple tasks in the same time, and distributed computing spread tasks across multiple machines in different location. And so the next one is cloud characteristics. So the first characteristics is on-demand self-services. So whenever we need, we can use it. Scalability, we can grow or shrink resources. Means we can scale up or scale down resources like cloud resources. And pay as you go pricing. So pay as you go means how much services you are using, that much you can pay and go. And accessibility from anywhere. So it's a remote thing, so you can access via internet. And automatic updates and maintenance. These are the key characteristics. So the main cloud characteristics are on-demand self-service. User can access computing resource like storage and servers whenever needed without human interaction. And second one is broad network access. Services are available over the internet and can be used from any devices. And resource pooling is nothing but shared resources are used to share multiple users dynamically, optimizing usage. And rapid elasticity, resources can be quickly scaled up or down. So elasticity means resources can scale up or scale down. We can add or remove resources based on your workload. And the last one is measured services. Resource usage is monitored and billed. That's what we said, like pay as you go. How much you are using, that much can be billed and we can pay. So the next one is pros and cons, benefits and challenges of cloud computing. So benefits like scalability, cost effectiveness, increased reliability and greater flexibility. And challenges are data security and privacy, because data are processed in clouds, stored and processed in cloud. And cost management, multiple cloud environment, performance challenges, interoperability and flexibility, high dependence on network. And so the elasticity in cloud. So elasticity is nothing but ability to automatically add or remove resources as demand changes, because the demand is not like same. So it depends on the workload. It may increase or decrease. So the property of a cloud to grow or shrink capacity for CPU, memory and storage resources to adapt to the challenging demands of an organization. So based on the organization requirement, the resources can be scaled up or scaled down. Advantage is help maintain performance and reduce cost. Because of this elasticity, the cost will be reduced and performance is increased. And the last one is on-demand provisioning. So on-demand provisioning provides resources dynamically as needed, optimizing resource utilization and cost efficiency. Because on-demand means whenever the demand is, then we can provide the resources. So on-demand provisioning means giving computing resources like server, storage and network when it is needed, instead of setting them up before it. Fixing resources to the process, we are going to fix as per the requirement we can provide. key aspect of cloud computing that enables business to be more agile, cost effective and efficient. So these are the topic we covered in the first unit. Thank you so much.